laws of physics make no preference for inertial frame of reference, so from my perspective here, I do not stir, and yet it's clear. The immovable object moves. So because of relativity, immovable objects cannot be. But what I think people normally mean by immovable object is something that if it's not moving, you can't make it start moving by pushing on it. So not an immovable object, but an unacceleratable one. Using Newton's second law, we know that an object's acceleration is equal to the total force on it divided by its mass, though you've probably seen this as F equals ma. So an unacceleratable object would be an object with infinite mass. An object so massive that no matter how big the total force F is, when you divide F by m, you always get 0. Of course, as we've said, not being able to accelerate an object doesn't necessarily mean that the object isn't moving. It just means that you can't directly change its speed. If it's not moving, then it'll stay not moving. And if it's moving at 100 miles an hour, then it'll stay moving at 100 miles an hour. So, what about an unstoppable force? Well, all the fundamental forces in nature are actually caused by particles, like photons or gluons or gravitons, that interact with an object and change its momentum. The only way to not be affected by a force is to not interact with it at all, like how electrons don't interact with gluons so they aren't subject to the strong nuclear force. Even light itself is an unstoppable force. Every photon that hits your body changes your momentum a tiny little bit, and there's nothing you can do about it other than avoid light altogether or become transparent. So all forces are already unstoppable. But my impression is that the phrase unstoppable force isn't really meant to imply anything about forces like electromagnetism or gravity, but rather something that you can... Suppose you're stuck on a desert island with no internet, no books, and an evil genius who will only let you off if you can tell him how much $1 million weighs. Luckily, you're a physicist, so you can weigh $1 million with your mind. Here's how it goes. We approximate. We don't know how much a dollar weighs, but we do know how big it is, more or less. A dollar is about 15 centimeters long and 5 centimeters wide. Now how thick is it? We don't know that either, but money is made out of paper, and we do know that those Harry Potter books were around 800 pages long, or 400 sheets of paper. And I think the books were about 5 centimeters thick, so that gives 80 sheets per centimeter. Now we can find the volume of a dollar.